Okay, so this unit is going to be on something called kinetics. Okay, now we've been talking about reactions, right? So you mix compounds together, you get some new compounds. Now we're going to get more into detail about it. We're going to be looking at the speed of those reactions. So different reactions have different speeds, and we call that reaction rates. So the speed at which a chemical reaction occurs is called the reaction rate. So as you guys know just from everyday life, the faster, the higher the rate, the faster the reaction, the lower the rate, the slower the reaction, right? Makes sense. Okay. And a lot of times there are multiple steps that take place in a chemical reaction. So when we have a normal reaction, right? You guys don't need to write this down. So this is a pretty basic chemical reaction. And up until this point, we've been just kind of looking at it as, oh, we get these compounds and we make this compound, right? But in this reaction, before it can get to the product, there's a lot of steps that need to take place. Like the N2 molecule needs to bump into these different H2 molecules, and they have to bump in at a specific angle. They need to bump in a specific number of times, and that's how we get the product at the very end of it. And so that's what we'll be looking at. So that whole process is called the reaction mechanism. And the reaction mechanism is the step-by-step molecular level view of the pathway from reactants to product. So how do we get from here, from the reactants, how do we get from there to the products? That's what the pathway is called. And it's very kind of annoying to look at because, like I said, you got to get N2 and it needs to bump into H2 at a very specific angle, a specific number of times with the right amount of speed. There's a lot of different things that go into it. Okay, it's not just mix these and get that. We're going to be looking a lot more in detail. Okay. Now, different chemical reactions, they take place at different speeds, right? So some of them are really fast, like explosions. Those are milliseconds, right? They go before we can even process it, that reaction is already complete. But some of them take thousands, even millions of years, such as like minerals forming on Earth's crust. Another good example of a slow reaction is rusting. You guys have all seen rusting on metal. So rusting on metal takes a long time, but it actually releases the same amount of heat as some explosions. It's just stretched out over a long period of time, so it's not gonna, blow up and be super hot. So there's different amounts of time. So here we have some examples. We got a bomb here that's 0.001 seconds. We got an explosion here that's 1 second. Rusting of a ship can take 30 years. It's 10 to the 9 seconds. And formations of different minerals and things like that can take 30 million years. 10 to the 15 seconds. Okay. Explosions, yeah. So the key point and the important thing is that reaction rates depend on the frequency of the collisions. Make sure you guys jot that down somewhere, or make sure you guys keep that in mind. Okay. The speed of a reaction depends on how fast, how frequent the collisions happen. Okay. The key thing is the more collisions there are, the higher the reaction rate. And this is good dating advice. If you want to holla at someone, you gotta interact with them a lot. You have to collide very often with them. Okay. And to all you gentlemen out there, any tree can be chopped down. Okay. You just need to get that axe and make a lot of collisions on that tree.
Oh my God.
And so same thing for you ladies as well. Okay. You don't want to interact too much with scumbag guys because you can get chopped down. You think there's no such thing as a friend zone, guys. It's not true. You can chop any tree down. Anyway, yeah, more molecule collisions, higher reaction rate. This is why it's called chemistry, guys. Okay, do you know how many dating principles I got out of chemistry? It's incredible.
He's married, so.
I am married, and that's how I got my wife. I chopped that tree down, dude. Anyway. All right, so for a collision to lead to a reaction, it has to have enough energy. So basically, the molecule needs to be moving with enough speed. It needs to have enough energy to break the bonds, okay, with suitable orientation for new bonds to form in proper location. So that kind of tells us what we're going to be focusing on this unit. We're going to be looking at the energy that's needed to break the bonds the suitable orientation, which means like the position or the angle that the molecules need to collide with each other, and the proper locations, okay? So you guys don't need to copy that down, but that's kind of a primer for what's gonna be happening. Okay, and so we're gonna be ending today pretty short with this right here, the factors that affect the reaction rate. And a lot of these, if you kind of think about them, they're common sense. Okay, so the first thing that affects reaction rate is the physical state of the reactants. Okay, physical state of the reactants. Easy way to think about this is solid, liquid, gas, is it aqueous, whatever. The physical state of the reactants. Okay, because if you think about it, if molecules need to collide with each other to react, right? What it's limited by is the area of contact, okay, between the reactants. So for example, if you take powdered medicine, it dissolves in your stomach a lot faster, right? Because it's powder, right? The stomach acid can touch more parts of the powder, as opposed to if you took a tablet, it's only limited to right here, the outside, right? And it needs to slowly break into the middle. And so the physical state is going to affect the speed of the reaction, because it's going to limit how frequently these can collide. So we have a little graphic right here. Okay. Any questions about that? Pretty common sense, right? Yeah. More contact, again, more contact, faster the reaction. Okay, you chop that tree down, okay? Increase the rate of chopping. Okay, text her, see her, call her. Actually, don't be creepy though. Okay? Because too much energy will destroy that molecule anyway.
That's your pickup.
That's true. And see, that's the strategy that goes into it, right? There are different ways to chop the tree down. Some are more efficient than others. For example, the taller you are, the better your probability.
The bigger the axe.
Right? The bigger the axe, exactly. Right? What else? I don't know.
Oh, the quality of the metal.
Yeah, the quality of the metal. See, you have to be a good axe to chop that tree down, right? Because let's be honest, everyone is beautiful in God's eyes, but the girl that you're trying to date is not God. And so you got to be pretty good looking, because, and this is important, guys, okay? Looks aren't everything, but when you wake up in the morning next to that person every day and they're drooling, no makeup, messy hair, right? And they're like half awake like that, they need to be good looking, or dude, that marriage ain't gonna last. And so it's important. Like, looks are important. And the snoring, dude, okay. You guys see my wife, right? Such a beautiful woman. That lady snores so much. Okay, I know my wife is never gonna watch this, and so that's why I can say this. But bruh, there have been times where she has waken herself up with her snoring. She's like, and she like looks around at me. I'm like, dude, that wasn't me. But anyway, so guys, this is why looks matter. Okay, it's not everything, but looks matter. Anyway, second thing that affects reaction rates, reactant concentration. This makes sense too. If you have more of a reactant, okay, it's gonna cause more collisions, right? So the higher the concentration, the faster the reaction rate. So here we have an example. I kind of wanted to do this, but we don't have 100% oxygen. Also, it's illegal to have it at school, and it's very dangerous. You can actually YouTube this. So steel wool, if you put it in air, right, it's which is about 20% oxygen gas around us, it will oxidize slowly. But if you have 100% oxygen and if you have steel wool, it'll just combust right away. It'll just burn instantly, okay? And so the higher the concentration, the more of something, a reactant you have, the faster the reaction, right? Which goes back to my example of height. The more of you there is, the faster that reaction.
So you're, in other words, saying short guys are
Hmm?
saying short guys.
No, dude, short guys have a chance, man. Dude, the thing I respect the most is when I see a short guy with a tall lady. Dude, mad respect for that. But height does help. Let's just be honest. All right, let's move on to number 3. The next one is reaction temperature, right? Remember, temperature is a measurement of how fast the molecules are moving, right? The faster they move, the more collisions, because the more energy, and so the faster the reaction. Okay, good example is milk. You keep in the fridge, it takes a long time for it to get yellow and chunky and sour. You leave it on your countertop, that thing goes bad real fast. Okay, and this is connected to dating because obviously temperature, the hotter you are, the faster that reaction. Yep. There's so much to learn about dating. If you sweat more. Interesting. Ladies, are you attracted to men that sweat a lot? Or is Mel just sharing something personal? Hey, no shame. Sweaty guys need love too. But yeah, I don't know. Maybe because it's because when you do exercise and stuff, you do release pheromones and things like that. Maybe.
Plus you get that pump in.
You do. Hey man, when girls show up to a basketball game, the guys play different. You guys already know. Guys get superpowers in front of girls.
Yeah.
All right, last thing is the presence of a catalyst. Now, a catalyst is a compound or chemical that increases the reaction rate without themselves being used up. So for example, we'll learn about these later, but basically the catalysts, they allow the proper collision to occur. So for example, let's say that we have a chemical here and then we have a chemical that looks like this. The only way for the reaction to happen is for this compound to collide this way, okay? A catalyst will help facilitate that. A catalyst helps that molecule go in the correct way, okay? And so this is kind of without being used up in the reaction. So this is kind of like your wingman, okay? This is the person that helps you get that in with that lady, right? Help start that conversation, okay? But that person is not used up in the reaction because he's not a part of that relationship. Once you get that relationship started, you boot your wingman because he's not a part of that anymore. Yeah, it just helps him. Okay, and yeah, we'll focus on catalysts a lot coming forward.
Enzyme.
Yes, enzymes are a type of catalyst, which you guys probably learned about in bio. Okay. All right, and I think that is it, the 4 things. Any questions on the 4 things? Okay, we're gonna do 11.1 just to see if you guys got the message. We'll do 11.2 next time, and then we'll be all done. Okay, so take a look at 11.1. We got 3 different examples of vessels with compounds in them. I just want you guys to figure out which reaction rate will be the fastest and explain why. So pretend this is an FRQ. Try to use FRQ language. And we're going to assume that all of the vessels are at the same temperature. Okay, so make sure you guys don't use terms like these compounds like this. They want to do that. You don't want to write that. You want to be very objective in your writing. Sorry. Am I tripping or is that let it go? Okay.
They were playing Encanto yesterday.
Oh, are they? Nice. Dude, I still haven't watched that movie.
Not yesterday, Wednesday.
Wednesday. Is it good?
As a Colombian, I have like qualms with it,
Oh.
but it's enjoyable.
Well, I don't know. I don't think you need to get perfectly culturally accurate.
I know, but
Like I watch Mulan and I'm not Chinese, but like when I see it, it's like, okay, for sure some of those things are exaggerated, but it's all good.
It felt really stereotypical. That's what it.
Dude, hey, okay, I'm gonna pause the recording real quick. It's probably because I'm pissing her off. All right, let's go over it. So, if you look at the reactions, I want you guys to show me with your fingers, 1, 2, or 3, which one is gonna have the fastest reaction? Yeah, peace, right? Number 2, good. Okay, so we would say here that what is it? Vessel 2. Or I mean, if you say reaction 2, whatever, that's fine. As long as you communicate the message, we'll have the reaction with the fastest rate. And of course, you're not going to write it exactly the way I write it, right? My English is broken and you guys can articulate it a number of different ways, but you want to hit on a couple important things. We said temperature is the same, so we don't need to worry about temperature. There's no catalyst mentioned, so we don't need to talk about catalyst. So we do need to talk about the other 2 things, right? The surface area and the number of collisions. And so here we can say that vessel 2, or the compounds in vessel 2, the compounds in vessel 2 will have the most collisions and have the highest surface area for the reaction. Okay, just that. That's it. Okay, because if you look at it, I mean, even if we measured it, right, there would be the most surface area here because it would get the area of all the little circles. We have the most, we can also talk about the concentration. We'll have the most collisions, the highest concentration, and have the highest surface area. So those 3 things, okay? So anything like that, I'd say the key things that you want to mention are the collisions, the concentration, and the surface area. As long as you got those 3 things in there, you're good. And I think that I would say if you just have concentration and surface area, you're chilling. Okay, yeah, what's up, Mel? So which one? 1 or you mean 1 and 2?
1 and 3.
Oh, 1 and 3. Good question. What do you think? 3?
Yeah.
Why?
Because those who are concentrated, they're just still left alone. They have to react.
Exactly. These aren't moving, right? So these will have the lowest reaction rate because even though there's a same amount of or less concentration here, they're moving, right? And so dating again, right? You can have more. There can be more of you, but if you're not moving around and you're not doing anything, it's not going to happen. So yeah, good question. Yeah, so it'd be 2, 3, 1 in terms of reaction rate. All right, that's pretty much it, guys. I'll have you guys chill for a bit, but I'm gonna go through the calendar and I'll update it for you guys because it is kind of out of whack right now. Probably get some dates for you. Probably subject to change, but yeah. Did you guys all pay for the AP?
Yeah.
Okay, just make sure you guys did that.
Someone took my